Hi everyone, I am Ranjita. Today we are going to discuss about the digital design and using a Verilog. In this, we are going to discuss about the off header and the full header. First, introduction to off header and full header. Off header and the full header are fundamental building blocks of digital circuits. They are used for performing addition operations in computer system. In this presentation, we will explore the concepts and working principle of both off-header and full header. Here we can see the off-header picture or a circuit diagram. We are going to use the AND gate and XOR gate and off-header overview. A off-header is a digital circuit that performs binary addition on two input bits. It has two inputs A and B and two outputs sum and carry. The sum output represents the least significant bit of addition, while the carry output represents the carry generated during addition. Here we can see that the half adder has the two inputs, that is A and B, and the two outputs, that is sum and carry. Truth table of the off adder. The truth table for a off adder shows all possible combinations of inputs and their corresponding outputs. The inputs A and B are binary digits. We know that the binary digits are the 0 or 1, and the output sum and carry are also binary digits. The truth table helps us understood how the off adder performs the addition. Here we can see that the off adder has the two inputs and two outputs, and the inputs are the A and B, and the outputs are the sum and carry. First, we are going to give some inputs to the A and B. That is, A is 0 and B is 0. We getting a sum as 0 and carry as 0. And then 0, 1, and we getting a sum as 1 and carry is 0. And again, we're going to give a is equal to 1 and B is equal to 0. Then the sum is 1 and carry is 0. Then A is 1 and B is 1. The sum is 0 and carry is also 0. Off-header circuit diagram. The circuit diagram of a off-header consists of the two logic gates, an XOR gate and an AND gate. The XOR gate performs the addition operation while the AND gate generates the carry. The input A and B are connected to the XOR gate and output sum and carry are obtained from the XOR gate and AND gates representatively. Here we can see that the off-header circuit diagram, we are going to use the AND gate and XOR gate. Next, the working of off-header. The XOR gate performs the additional operations by producing a one output when one and only one input is 1. And the AND gate generates the carry by producing a one output only when both inputs are 1. The sum output is obtained directly from the XOR gate while the carry output is obtained from the AND gate. Full adder overview. A full adder is a digital circuit that performs a binary addition on three input bits. It has three inputs A, B, and carry in, and two outputs sum and carry out. The sum output represents the least significant bit of addition, while the carry out output represents the carry generated during the addition. In the full adder, we having three inputs, that is A, B, and carry in, and two outputs, that is sum and carry out. Here we are going to use the two OR gates and three OR gates and two AND gates. A truth table of the full adder. The truth table for a full adder shows all possible combinations of input and their corresponding outputs. The inputs A and B and carry in or binary digits 0 or 1, and the output carry and the carry out are also binary digits. The truth table helps us understood how the full adder performs the addition. Here we are going to give some inputs to the A, B, and C in. When we are going to give the A, B, C in is equal to 0, we're getting a sum 0 and carry is also 0. And again, the AB is equal to 0 and C is equal to 1. The sum is getting 1 and carry is again 0. And then A is equal to 0 and B is equal to 1, C is equal to 0 and the sum is 1 and carry is 0. Then A is equal to 0 and B is equal to 1 and C in is 1, the sum is 0 and the carry is 1. The A is equal to 1 and B is equal to C is equal to 0, the sum is 1 and carry is 0. Then we are going to give again the A is equal to 1 and C is equal to 1. The sum is 0 and carry is 1 and A is equal to B is equal to C is equal to 1. Then we getting a sum is 1 and carry is also 1. Next, the full adder circuit diagram. The circuit diagram of a full adder consists of a three logic gates, two XOR gates and one AND gate. The XOR gate performs the additional operation while the AND gates generates the carry. The inputs A and B and carry in or connected to the XOR gates and the outputs sum and carry out or obtained from the XOR gate and AND gates representatively. Here we can see the full header circuit diagram. We are going to use a two XOR gate and two AND gate, one OR gate. Working of full adder. 2 XOR gate performs the addition operation by producing a one output when one and only one input is 1. And the gate generates the carry by producing a one output only when two or more inputs are 1. The sum output is obtained directly from XOR gates while the carry output is obtained from the AND gate. Advantages of off adder. The off adder is simple and requires the fewer components compared to full adder. It is faster in terms of propagation delay compared to a full adder. The off adder is suitable for adding a single bit of or performing a simple arithmetic operations. The limitations of off-adder. The off-adder cannot handle carry inputs from previous bits, limiting its usefulness in multi-bit addition. It cannot produce a carry output, making it unsuitable for adding multiple bit together. Thank you, everyone.